Hello everyone. So this is Cadet Baran Matthew and today we are going to do our Eplan C.
So in this activity, we are given the scenario description. At 1200s, the vessel is the vicinity of Lagonoy Gulf with by visual observation using the magnetic compass, the OW observed Sialat Point and Agoho Point in transit which bore 345 degrees per standard compass. And we have the initial condition of ship's course which is 335 degrees per standard compass and has speed of 60 knots.
So the first thing we need to do is to update um, the variation on this chart. So the given variation on this chart is 1 degrees and 15 minutes west and has the 2013 year and has 2 minutes west variation every year. So the first is um, to subtract the current year, which is 2021, in the year of the variation in the chart, which is 2013. So it's equals to 8. And after that is we need to multiply the variation every year, which is the 2 minutes west. Multiply by 2 minutes west. And we will get the answer of 0 degrees and 16 minutes west. Next is to add the the variation of the 2013 chart, which is 1 degrees and 15 minutes west, because it has the same direction. So we need to add, and we will get 1 degrees and 31 minutes west, or round it off into 2 degrees west. So that would be our variation. So in the given, we have the compass bearing, which is 345 degrees per standard compass. So in order to correct this, we need to use the CDMVT in order for us to get the true bearing. So after using this, we will next find the deviation. So in order to find the deviation, so since this compass course is in between the 340 and 360, so we need to interpolate it. So first thing we need to do is to get since 345 is in between 340, and we will write the 345, and also between 360. So in this part, we will find the difference of the 345 and the 340, which is 5 degrees, and the 360 and 340, which is 20 degrees. Next, since the 340 has the deviation of um, 4 degrees west, and in the deviation table we cannot find the 345 because it has no deviation, so we will put X here, and then 360, which has the deviation of 6 degrees west. So we will find the difference. So X minus 4 degrees, so we cannot find any value, and here is 6 minus 4 will be 2 degrees west. So now I will be going to compute. So we will use this deviation, 4 degrees west, 4 degrees west, and then we will add bracket 2, which is this, 2 degrees west, and then multiply by the difference of the headings, compass headings, which is 5 divided by 20 degrees. So we need to compute this first. So 5 degrees divided by 20 degrees is equals to 0.25, and then 0.25 multiplied by 2 degrees west, or 2 degrees, is equals to 0 degrees and 30 minutes. And then lastly we will add that 30 minutes to the 4 degrees west. 4 degrees west added by 0 degrees and 30 minutes is equals to 4 degrees and 30 minutes, and if we will round it off, it will become 5 degrees west. So we will use this one as our deviation. So our deviation here is 5 degrees west. So in order to find the magnetic heading, is since we used CDMVT, so we will subtract west and add east. So since our deviation is 5 degrees west, so we will subtract in order to get the magnetic heading. So 345 minus 5, that would be 340 degrees. And then here, our variation, we will use the current variation of this year would be 2 degrees west. So 2 degrees west, and then since it is west, so we will minus the 340 on our variation. So magnetic heading minus our variation, which is 2 degrees west, and we will get 338 degrees as our true bearing. So next is, since we are given the initial compass course, which is 335 degrees per standard compass, so we will use again the CDMVT in order for us to get our true course. So we will again interpolate, since we cannot find the 335 in the deviation table. So Since the 335 is between 320 degrees and 340, so we will use these two um, deviation compass heading to get our deviation of in the compass heading of 335. So we'll use 320 degrees and write our given, which is 335 and 340. So we will find the difference, which is 15 degrees, and the difference of 340 and 320, which is 20 degrees. And the deviation of 320, which is 3 degrees west, and we cannot find any deviation of the 335, and the deviation of 340 rather is 4 degrees west. So we cannot find any difference, and here is we have 1 degrees west difference. So we'll use again the formula. Use this 3 degrees west added to this, which is the difference of the 4 degrees and 3 degrees, which is 1 degrees west, multiplied by the difference of the compass heading, which is 15 degrees divided by the 20 degrees. So first we'll use we will first divide 15 degrees divided by 20 degrees, and we will get 0.75. So next is we will multiply 0.75 to 1 degrees west, or 1 degrees, and we will get 0 degrees and 45 minutes west. And lastly, we'll add, so 3 degrees west and added by 0 degrees and 45 minutes, so we will get 3 degrees and 45 minutes west, or round it off, and we will get 4 degrees west. So we will use this deviation in order to get our true course. So 4 degrees west, and in order to find our magnetic heading, we will use subtract, since we're using CDMBT, and we will minus west and add east. So 335 minus 4 degrees west is, we will get 331 degrees as our magnetic, and we will use the same variation, which is 2 degrees west, and in order to get our true course is, we will minus 331 minus 2 degrees west, so we will get 329 degrees as our true course. So in this part, we are going to plot our true bearing and our true course. So we will use these two triangular rulers in order to plot our true bearing and true course. So since we found out that our true bearing is 338, so we will find 338 in our compass rows. So here, and since it is on the Sialat point, so we'll move it here. is this would be our true bearing. Next is to locate our ship's course. So that would be 3 to 9. So 3 to 9 is here. And we'll move it here. Since our ship is sighted on the Lagonoy Gulf, so probably this is our ship's. This would be our true course, and true course, which is 3 to 9 degrees, and true bearing is 338 degrees. So that would be all. Thank you.